In this video, I want to look at how we actually work with sigma notation, and we're going to look at some very basic properties. The first property is one that we've already mentioned in an earlier video, which is that the counter variable is a dummy variable. So the counter variable is a dummy variable, meaning its name is unimportant. In other words, if I have the sum as k goes from 1 to n of ak, that will be a1 plus a2 plus all the way up to an. And let me make my dots look just a little bit better. And if I have the sum as j goes from 1 to n of aj, that's also going to be a1 plus a2 plus all the way up to an. And of course, these two things are equal. So what that tells me is that the sum as k goes from 1 to n of ak is the same as the sum as j goes from 1 to n of aj. In other words, it doesn't really matter what variable we use for the counter. The second property that I want to think about is that we can break sums up. So breaking sums up. And we can break them up at plus or minus signs. And again, what I want to do is I want to kind of look at a particular sum. Suppose I have the sum as k goes from 1 to n of ak plus bk. In other words, my term has a plus sign in it. Well, what this particular notation represents is it represents a1 plus b1 plus a2 plus b2 plus all the way up to where we finally get to an plus bn. Now, addition is both commutative and associative in the real numbers, so I can gather up all of the a's, and I'll do that first, and then I can gather up all of the b's. And when I do that, I actually am looking at the sum as k goes from 1 to n of the ak's, and then I'm going to add the sum as k goes from 1 to n of the bk's. And so it's important to realize that we have a formula that says if I've got the sum as k goes from 1 to n of something that looks like ak plus bk, I can break it up at that plus sign and write this as two sums. The sum as k goes from 1 to n of the ak's plus the sum as k goes from 1 to n of the bk's. Now, the other thing that I want to mention is that there's nothing special about a plus sign. I could have a minus sign here that would put minus signs in front of all of the b's, and so that would put a minus sign here. In other words, I would factor out a minus sign, and that would put a minus sign here, and that would put a minus sign here, and that would put a minus sign here. So this plus sign can be replaced by a plus or minus sign in the appropriate way. The next property that I want to look at is that I can bring constants back and forth through the sigma sign. So constants float across the sigma notation, the same way that constants float across differential notation and across integral signs. In other words, if I have the sum as k goes from 1 to n of c times ak for my term, that would be c times a1 plus c times a2 plus until I get to the last term, which is c times an. And I can factor out this c and write it as c times a1 plus a2 plus all the way up to an, and this would be c times the sum of k goes from 1 to n of the ak's. So as a formula, if I have a constant inside the summation, I can bring it outside the summation Of course, this goes both ways. If the constant is sitting outside the summation, I can bring it inside the summation. So those are our very basic properties of sigma notation.